Welcome to the introduction to kinetic theory of gases. As you can see in your handout, we have the objectives for the unit right here. We're going to be working primarily on solving problems involving the relationship between temperature, pressure, and volume for a fixed mass of an ideal gas, and to some extent analyzing gases. The first thing that we really need to get a grip on is the idea of the kinetic theory of gases. The basic ideas are laid out in your book in the reading that I put on the handout. Gas particles are negligibly small compared to the container they're in. That simply means there's a lot of space between them for them to move around. Gas particles have no attractive or repulsive forces between them. Well, actually not true, but at room temperature that more or less seems to be the case, so we can use it. The collisions are perfectly elastic, no energy is ever lost, and it's the collisions that actually cause pressure. And finally, the kinetic energy of the gas particles is directly proportional to the temperature. If we take a look at the Moodle, you'll see that there are a variety of gas laws simulations. The one that we're going to look at first is the one that says temperature and kinetic energy simulation. If we look at the temperature and kinetic energy simulation, it looks like that. In order to make sure that you see what you should see, be sure that you have ticked the box that says heater. You slow the simulation speed down. That is actually modeling gas particles moving around. If you look at the walls of the container, you can see that the particles are colliding with the walls of the container. That collision, that is what causes pressure. If you increase the heater temperature, then you'll see that the particles start going faster and faster and faster. That makes the collisions here more and more frequent. The more frequent the collisions are, the higher the pressure. And the faster the collisions are, the higher the pressure. That's the general basis of the kinetic theory of gases. Now, if you lower the temperature, you'll see it go in reverse. The molecules will slow down. There will be fewer collisions with the walls of the container. The collisions will be slower, and the pressure in the container will actually go down. One thing we have to be very sure of when we're working with gas laws is that we're using Kelvin temperature scales. In Kelvin temperature scales, 0 is actually absolute zero where all motion stops. And that is 273 degrees below Celsius. So, 273 degrees below 0 Celsius. So be sure when we're working problems that you're using these relationships here in order to convert your temperatures correctly. Finally, when we are working problems, we're going to run across the phrase STP, standard temperature and pressure. The standard temperature is 25 degrees Celsius or not 273 K. But 298 K. And standard pressure is 1 atmosphere or 101.3 kilopascals. These can be found in the front of your data book. Now, the next little video that you will see is me walking you through the idea of the graphs of pressure, volume, and temperature before we proceed to problem solving.